Hello and welcome back. In this video we will be looking at exponentials and logarithms. These are going to be used extensively throughout the semester, so I just wanted to quickly go through what exponentials and logarithms are and what they do. So an exponential function is a function where we're taking some number b and we're raising it to the x power. For this to work, b has to be a positive number, and we also want that b is not equal to 1. If it's equal to 1, 1 to any power is just itself. So it's kind of a boring function, and it doesn't satisfy a lot of the same properties as what would happen if b were a positive number that weren't 1. So let's look at the function f of x is 2 to the x power. So if we were to plug in 0 into this function, for instance, we'll get 2 to the 0 power, which is always 1. When x is equal to 0, f of x will be equal to 1. If we plug in a 1, we get 2 to the first power, which is going to be 2. If we plug in a 2, 2 to the second power will be 4. If we plug in a negative 1, 2 to the negative first power, which is 1/2. And then 2 to the negative second power will be 1/4, and so on. So we're going to get this line that's going to start going up pretty rapidly, and this is where you'll hear a lot of say non-mathematicians say something is exponentially growing is because an exponential function grows pretty fast. It isn't always because there's an exponential function beneath the surface. For the domain and range of this function, it's just good to keep in mind that we can plug in any number that we want into an exponential function. We can take f of any number that we want. We can plug in 13, negative 37, it doesn't matter what it is, there's no restrictions on here. The range, however, if you take 2 and raise it to a power, you can never get a negative number. So the range is going to be all the numbers strictly greater than 0. We can't even take 2, raise it to a power to get 0. If you take 2 times itself a bunch of times, it's positive. If you take 2 divided by itself a bunch of times, it's still positive. We can never get 0. So this is just something to keep in the back of your mind. You can always plug in any value you want into an exponential function for the domain, but we can only get positive values. So for instance, we could take a look at a couple of questions here. So let's solve for x. 3 to the x power is going to be 81. Well, if we think about this, 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So that's 4 copies of 3. So we know that 3 to the 4th power is 81. And in fact, we know that 3 to no other power should be 81. If we raise it to a higher power, it'll be bigger. Raise it to a lower power, it'll be smaller. So in fact, x has to be 4. Cool. So then we can look at this question, and we've got 3 to the x power is equal to 30. Well, okay, so 3 to the first power is 3, to the second power is 9, to the third power is 27. That's pretty close. To the fourth power, we're already at 81. So it's somewhere between 3 and 4. And we don't actually have enough tools to be able to solve this right now. It's going to be between 3 and 4, probably closer to 3, since 30 is closer to 27 than it is to 81. But what we need is another tool in our back pocket. So we're going to use logarithms. And logarithms are the inverse of exponentials. So when we have an exponential, when we write b to the x is equal to y, we use the logarithm to sort of flip this over. So we still have this base in here, so we're still talking about that exponential is still hidden in there, but the log base b of y is now equal to x. So essentially we can swap x and y. So let's put this to use. If I have log base 3 of 9. So that's asking if I were to, if I said that this was equal to y, then this would be saying that 3 to the y power is equal to 9, and we know that 3 squared is equal to 9. So log base 3 of 9 is 2. Over here we have log base 5 of 1 over 125 is equal to something, and we don't know what it is. So we can turn a logarithm into an exponential by swapping these positions. So it'll be 5 to the y power is 101 over 125. And 125 is 5 to the third power, so 1 over that. This is going to be negative 3. One thing to keep in mind, there's a couple of nice facts here. Log base b of 1. So if we think about this, this is asking log base b of 1 is equal to y. This is saying that b to the yth power is equal to 1. And luckily, there's a number that satisfies this. Anything to the 0 power is always 1. So this is a good fact to keep in the back of your mind. Log base anything of 1 is always 0. And we get a similar thing happening over here. If I want to solve log base b of b is equal to y, well, this is saying that b to the yth power is equal to b, and we know b to the first power is b. So log base b of itself is always 1. So these are a couple of nice functions to keep in the back of your mind. And one thing that you'll notice in here is that so let's look at this one over here, for instance. 9 is in fact 3 squared, which is how we know that this answer is 2. So if I take log base 3 of 3 squared, what you'll notice is that this is going to be 2 times log base 3 of 3. This is maybe a little bit weird for the moment, but as I write this down, you'll notice that this 2 kind of comes out front. So log base 3 of 3 squared, we know this is equal to 2, but I can write 1 as log base b of b, so why not log base 3 of 3? And this gives us the following rule. Log base b of x to the n is equal to n times log base b of x. Essentially, this exponent up here comes down front if we're taking a log. And this is what we'll use to solve, for instance, this last question. So before, we said that, we don't really know enough to be able to say 3 to the x power is equal to 30. What is x? Well, what we'll do is we will take a log of both sides. And in particular, I'm going to use log base 3. So if I take log base 3 of 3 to the x power, and I do this to both sides, now I get to use my power rule, and I get to bring this x down. So again, anything in this exponent gets to come down front. So x times log base 3 of 3 is going to be equal to log base 3 of 30. And log base 3 of 3, this is just 1. Log base b of b is always 1. So this gets canceled out, and we know that our answer is equal to log base 3 of 30. This is perhaps unhelpful, and we would just want to plug this into a calculator to see exactly what this is. If you do plug this into a calculator, you get about 3.0959, I believe, rounded to 4 decimal places. And this fits with our assumption. 3 to the third power is 27, which is pretty close. So we just have to take 3 to a little bit higher power, 3.0959, and we get all the way to 30. Let's do some more examples. So here, this one looks a little bit trickier, but with some tricks, we'll be able to solve this. So it's 5 to the x squared times 25 to the x power is equal to 5, and we want to solve for x. So right away, this is looking a little bit complicated, so I want to simplify this as much as I can by consolidating terms. So first and foremost, I've got a 5 to a power and a 25 to a power. I would rather just have 5s all across the board. So if I take 5 to the x squared. 25 is in fact 5 squared. A nice trick. And we're going to raise that to the x power is equal to 5. And 5 is just 5 to the first power. I might as well write that down. So 5 to the x squared times 5 squared to the x. When I raise a power to a power, so with our exponents rule that we saw before, this is just going to be 5 to the 2 times x. And that's equal to 5. And then over here, we've got when we multiply exponentials with the same base, we add the exponents. So this is going to be 5 to the x squared plus 2x. And this is going to be equal to 5 to the first power. Okay. And now we see all these exponents up here. And what I would like to do is just say, oh, 5 to a power is equal to 5 to a power. Those powers should be equal. Well, we can also prove this. Let's take log base 5 of both sides. Using our power rule, we get to bring down our exponents. So this is going to be x squared plus 2x, that's the exponent over there, times log base 5 of 5. And over here, the exponent is just 1, and log base 5 of 5 is just going to be 1. Well, and also log base 5 of 5, that's just going to be 1. So ultimately, we've got x squared plus 2x is equal to 1. And then this is just simply going to be a quadratic equation. So we've got x squared plus 2x minus 1 is equal to 0. And this is something that we could use. We could try to factor this. We could use our quadratic formula, or even trying to complete the square. So this is something that we know how to solve. And I'm just going to leave this here. So there will be 2 solutions. 2 solutions to this. So let's continue and look at some more questions here. So here we've got 3 to the x plus 1 is equal to 2 to the x power. So again, we've got exponents upstairs that we need to bring down, so we need to take some logarithms. However, which logarithm do we choose? Do we use log base 3, or do we use log base 2? The ultimate answer is it won't matter, because our power rule, it doesn't depend on what base you have. The base has no effect on anything. It doesn't matter what base you use, you will always bring down the exponent. So so here I will define a new type of logarithm. If we use log base e, e is a common exponential number. This is what we call the natural log, which we abbreviate with ln. So this is what I'm going to use over here. I'm going to take the natural log of both sides, the natural log being one that is used quite often. And then I can bring both of these down. So we've got x plus 1 times the natural log of 3 is equal to x times the natural log of 2. And I want to solve for x. So let's do that. So I will distribute the natural log of 3. So we've got x times the natural log of 3 plus the natural log of 3 is equal to x times the natural log of 2. We'll subtract this from both sides. So we've got x times the natural log of 3 minus x times the natural log of 2. And I'll move this to the other side as minus the natural log of 3. And then solving for x, I'll pull out an x. And dividing both sides by the leftover, we get minus the natural log of 3 divided by the natural log of 3 minus the natural log of 2. And this would be our answer, which we could plug into a calculator to compute an actual value for this. us.